Assalamualaikum warahmatullahi wabarakatuh. My name is Anisha. I will present about my work, Natural Language Interface to Database for Decision Support Query. This is the outline of my presentation. I will start with research background and then I will try to explain about objective, analysis, implementation, testing and results, and finally conclusion. Research background. Accurate, fast, and right data accessing are a modern requirement for business decision analysis. It is very useful for business leader or stakeholder to identify trends, visualize data, and get the insight to make the right business decision quickly. SQL or Structured Query Language is formal language that can be used to access data to database. Some of obstacle in writing SQL command is user need to understand the content of the tables and relationship between tables, and difficult to write the structured SQL command when it involves more than one table or joint table. So to meet need export for accessing data, it is necessary to design a user-friendly interface, as user can submit data requests using natural language. NLIDB, it is a system that allows users to access information from a database by entering requests in natural language. This is an overview of process NLP with NLIDB. Natural language as input can be processed with NLP, and then the result from NLP can be generated into query SQL. Natural language interface to database for Indonesian language has built. There are NLIDB which can translate imperative sentences into simple SQL query and NLIDB which can translate question sentences into SQL query. And however, both have limitation in handling type of aggregation query, join clause, saving clause, and query containing time and date. Even though this type of query are usually used to obtain decision support data. Objective. The objective of this study is recognize imperative sentences, develop the stage of translation, and develop an NLIDB application that can translate imperative sentences for decision support query into query SQL based on the translation method. Analysis. First, analysis of decision support query to SQL query. According Antonio, there are 4 examples of query that are often used for decision support. There are pivot or cross-tab query, hierarchical query, trend query, and correlated aggregation. And Manuel, according Kale and Kosman, top end and bottom end query. This is a other type of decision support query. And this is a table, a grouping type of decision support query to SQL query. Based on the literature review, there are 5 types of decision support query, but not all query can be handled with SQL query. So, pivot or cross-tab and trend query can be created with cross-tab query in SQL, manual, hierarchical correlated aggregation, and top-end or bottom-end query can be created with summary query in SQL. And this is analysis of imperative sentences. This is a general structure of imperative sentences for decision support query. The structure of the imperative sentences in the study use the basic pattern of the syntactic construction. This structure have roles TOK. T as predicate is category transitive verb. For this section, there are imperative words. O is object as constituent of noun or phrase noun. Phrases that can fill this section are number of data, aggregation request of phrase or conditional phrase or data group phrase or data sorting phrase. And for adverb section, this is a section for For short information about a sentences, the phrase can be filled in the section is data grouping phrase or conditional phrase or data sorting phrase. And this is structure of imperative sentences for core-step data request. The characteristic of the imperative sentences for this data request consists of two or more data grouping phrase in the adverb section, and for conditional phrase and or data sorting phrase is optional. And this is structure of imperative sentences for summary data requests. The characteristic of these sentences is there are one data grouping phrase in the adverb section, and for conditional or sorting, this is optional too. And then structure of imperative sentences for 10 data requests. The characteristic of these sentences, there are consist of the word perkembangan or pertumbuhan as the keyword of these sentences in the object section, and there are time conditional phrase as a specific time or time condition with a year dimension as the 12. And then for structure of imperative sentences for top and or bottom end data request, there are a number of data in object section, and there are data sorting phrase. There is the word superlative begin with a fixed or falling. And this is a method of translation. The preparatory stage of parser tool. This stage was carried out before the translation method processes. We use PCPATR as a parser tool, and then we use the grammar and lexicon file that created by Joyce, and adding context-free phrase structure and feature constraint for imperative sentences to fill grammars such like this. And this is a method of translation. There are four main processes. There are analysis of parse tree, searching object to ontology, building SQL query, and executing query to the BMS. For analysis of parse tree, we choose node object for searching for select attribute section, searching for select aggregation section, searching for having section, for order by section, and limit section. And then we use node cut or keterangan for searching select attribute section, searching for where section, and group by section. After that, we are searching object to ontology for each section SQL. After that, we collect all the objects and search relation between object class. After that, building query SQL with cross-step query form or non-cross-step form, and then executing query to the BMS, and finally show the result of translation to user. And this is analysis of the parse tree. For example, node of parse tree for get part select aggregation is object recognized by word, that's mean aggregation function. For example, rata-rata, that's mean average function. Implementation. For build this NLIDB, we use the NLIDB approach. There are NLIDB, which is the syntax-based approach. This approach is provide detailed information related to synthesis structure, and NLIDB with ontology approach. This approach is simple and effective method of understanding knowledge and concept discovery. With this approach, to build natural language query, relational database are transformed into ontology, and database ontology are also mapped. And this is a system architecture. We adopt the modified NLIDB architecture from Gasani. There are 5 main components for this structure. There are user interface. This component used to receive imperative sentences from user and then display the translation result and display error message. Query analyzer. This component for process sentences and translate uh, phrase and token into function or operator in SQL. Query generator, this component for build SQL query. Ontology builder, this component for build ontology from database. And database interface, this component to read database metadata, send SQL query to the BMS, and execute and receive the result of SQL query from the BMS. And this is a user interface of NLIDB for the first user entering sentences according structured imperative sentences. And then application we call parser to parsing sentences into parse tree, and application we show the parse tree to user. After that, application will translate sentences into SQL query and show the SQL query as the result. And finally, application will show the result of the query SQL execution for the BMS in the table form. Testing and result. Testing for this NLDB was carried out with two testing. First, testing for result of translation query and testing for component performance in translating sentences. This is testing for translation query. The test scenario for the result of the imperative sentence translation was carried out by testing each data query using metric like this. And then testing for component performance. The scenario is entering all query requests for recent support data that's combined with possible query to the application. The component that's analyzed in the test are query analyzer, query generator, and database interface. This is result of performance component testing. This table of result performance component testing show the query generator component has a longer execution time than other components. And the last conclusion. All types of decision support query have sentences structure that contain verb, object, and adverb. Verb imperative sentences for top end or bottom end data request is recognized by numeric word at the beginning of the noun phrase as a limit clause, and separated word which have a fixed filing order in object section. For imperative sentences, for requesting trend data is indicated by word perkembangan or pertumbuhan in the object section and the time phrase as the condition of the time period in the adverb. For imperative sentences, for cross-type data request is recognized by two grouping data process in the adverb, and manual a summary data request is recognized by one data grouping in the adverb. The translation of imperative sentences for recent support data requests in SQL query was carried out by identify characteristic of the imperative sentences, and then parse sentences into a parse tree by PGPATR tool, and then analyze node of parse tree to get part of SQL, search object to ontology, and the last build SQL query into non-cross type query or cross type query. Thank you.